Hi class, this is Mr. Pickett, and I want to talk a little bit about not just water quality, but how we get water from, I guess, kind of nasty water, wastewater that we produce every single day, to the water that you're able to drink and that's capable of being put in your home. Um, Number one fun fact that the book kind of tells us a little bit is, and I'll write this down, 53. Every single day, the average American uses 53 gallons of water and turns it into waste. This could be from a lot of different processes, but 53 gallons of wastewater ends up going and leaves our house and goes somewhere. And a lot of times we don't think about where that water goes, but as we found out, water comes from somewhere and goes from somewhere, even in the Emmitsburg area. And where it's coming from and where it's going is pretty important, especially as we're changing the water, because we know that having clean water is really important. So whenever we flush the toilet, whenever we turn the faucet on, whenever we put something down the drain, whenever we just throw something in the sewer, or whenever we cut the grass and it drains into our sewers, we're actually adding water into our water system. And it's important for us to understand how we can take the water from a polluted or just really a wastewater standpoint and turn it into something that we have the ability to use again, and that other organisms besides human beings have the opportunity to use it and not get sick. So what ends up happening is water that comes from our homes or really anywhere else ends up going to a treatment facility. So that's really the first step, is that water goes to a treatment facility. These facilities are generally on the river or next to a big body of water, and they end up pumping water in. And one of the first things that ends up happening is they get put into a holding tank. And it's really, that's really the next step. They go to a treatment facility and they go to primary treatment. And what happens in primary treatment is basically we have a big tank. The water's pumped into this tank and fills the tank up. And I'll just go ahead and fill the tank up. Awesome, lovely tank, lovely water tank. And what will end up happening is two things. Number one, very, very solid particles that have been dissolved in that water or just that are floating into it end up kind of settling down to the bottom. They call that sludge. So what will end up happening is sludge or other stuff that's down there will end up collecting at the bottom. And that sludge is literally pumped out, drug out of there. And also at the top, there's kind of this weird foamy layer where a bunch of oils or other things that are there end up going off the top, and they end up getting skimmed off, a lot like butter. We're churning butter and you end up having cream at the top. They end up just skimming that very top layer off. So that's the first one. Really nothing that crazy that happens here, just things that really are more dense than water that are with it end up going to the bottom, and things that are a lot less denser than water rise to the top. And so we've already done a little bit of water treatment for us and already made our water even cleaner. But this water is not clean to drink. No way. We still have lots of different things. We still have bacteria. That's probably the main thing. That's kind of a dangerous thing. And a lot of other dissolved particles. We have a lot of other dissolved particles. Those particles can be metal. Those particles can be radioactive materials. Those particles can be not just particles, but they can be other things besides bacteria. There can be some viruses that are located in there. So what we're doing is that we still have to go to another treatment option. And that second treatment, or excuse me, that next step is called secondary treatment. And the secondary treatment's an interesting one because we put it into another holding tank. So I'll make another holding tank. And we pump the water in. And again, same thing happens if we let these things sit for a while. More sludge will continue to accumulate at the bottom. But we also introduce something else into this holding tank. And what we end up introducing is our own bacteria. And what will end up happening is, two things are introduced. we introduce our own bacteria. So we introduce good bacteria. And we introduce some oxygen. The good bacteria feeds off of that oxygen, and what the bacteria will end up doing is it will consume even more of the dissolved particles that are inside of that water. And so the good bacteria does its job. It eats, and eventually it dies. And the bacteria, because it dies, ends up collecting to the bottom. It accumulates into more sludge, and we're able to suck that stuff out, just like we did before. And generally, once we're done with that, we add chlorine, which will end up killing about 99% of that bad bacteria. And then we pump it out to consumers. We dump it right into a river, right into a lake, and we let it go on down the line. And I find that interesting. I don't think a lot of people understand that's what we do. You know, number one, we just let it collect, and we let things just use density to either fall or to rise, and then we take those bad particles away, and then we actually introduce our own bacteria in there. It eats a bunch of the things that we don't want to have in there, and then the bacteria ends up dying, and we speed that process up too by adding chlorine, and that's usually what we end up doing. We end up discharging that stuff out into the environment from that point on. Now, the water that you drink doesn't just come from a river or a stream. We have a lot higher standards about the things that we drink. There's a lot of things that have to go into it, and there's a lot of other purification steps that we have to accommodate. But what we put back into the environment is basically that. Now, why is this important to you guys right now? I think about 2 or 3 weeks ago in our newspaper, in the Emmetsburg newspaper, it was voted on to have everyone in the community have a $5 charge on their utility bill. And I think I'm saying that right. And the reason for the increase is because the state has demanded that the levels of copper, and I think also the levels of chlorine, if I'm right, have to be, or chloride, have to be decreased significantly. There's some standard that the state's asking, not asking, but telling communities and water treatment facilities they have to get to. And because we have to do that, the community of Emmetsburg and Palo Alto County has to invest a lot of money in some new water treatment technology. What does that mean for the consumer? Well, number one, it means that yes, you have to pay more money. And I believe the reason they're doing that is because they don't know exactly the cost that it's going to take to update their facility plan. And so this is going to hopefully help them. But secondly, you're going to get water that has less dissolved copper and some other particles that are accommodated with that. So I don't think that's really a lose thing for everybody. I don't think that it's necessarily, copper isn't something that we want to be drinking in high qualities. So now there's lots of other procedures that people use to purify water, but those are the main steps. I just want to talk to everybody. You guys are going to be watching a video here too, also about a water treatment facility, so that way you guys can see that. But some pretty interesting stuff. Have a great day, everybody.